In this video, we'll talk about how we implement the Excel model for the contract award problem. So if we look at the problem again, it's basically a transportation problem plus some side constraints. Okay, so what we're going to do will be implementing the basic part, the transportation problem part first, and then we're going to add those side constraints. Now, if you can go to the data file, just copy the given data to a new sheet. And going to enlarge this side. Okay. And then we'll quickly do the transportation problem first. So I'm going to copy this entire part to here and delete all those values here, because we know in all the transportation problems, what we usually do is that we highlight those areas as our decision variables. We have one decision variable correspond to one unit cost, like the transportation cost. Okay, and then we're going to move this row here and move this here, because later we're going to put those constraints, and one constraint, and each supply or demand node will have one constraint. So here we're going to have total tons shipped, or say delivered, okay, or received. Larger, okay, and here will be total tons shipped. Okay, and this one will be the sum of these ones. And this should not be, so none of those will be the currency. So let's change the number setting back to just a number. Oh, and we don't want decimal points here. Okay, so this one will be sum of all of these ones, and this will be the sum of these three. Okay. Okay, so with this, we took care of the decision variables and the constraints in the basic transportation problem. Okay, and also we're going to put our total cost. So the objective function, we'll just put it here, total cost. So the total cost is the sum product of the unit cost matrix and the decision variable matrix. I'm going to highlight this in blue. That's what I always do for the objective function. Okay, so this part is pretty easy. That's it's basically this part. We're going to make sure the supply, so the left hand side will take the sum of them, that's equal to the total supply, and the demand part will take the sum of the left hand side and make them equals to the required times delivered. And the objective function, now we'll take care of those side constraints. So if we look back, the first side constraint, company 1 will not supply orders of less than 150 tons for any project. When we analyze this problem, we know this is kind of like the minimum size problem, minimum order size problem. And its corresponding constraint is this one. So for all the companies, they will have to be less than equal to the big M times their Y, and greater than equal to this minimum order size, which is 150. So the implementation of the Excel model will use the same format. We'll have the basic model here, and then we'll have our side constraints. Okay, so we'll put additional constraints. Okay, then the first one, company 1 batch size, or like the minimum size, it's 150. Okay, so we'll list it here, and we'll say those are the Y. We're going to have those of the YIIs. Oh, actually, they are Y. If we go back to look, it's the Y1I. Oh, Y1J. So those are the Y1J. The Y1J. We have 4 of them. We're going to shade them in yellow to represent our decision variables. And now here would be the linking constraints. Okay, so we want our minimum, the minimum multiply the Y1J, and we also want the big M, the big M. Let's just do the big M, and the M multiply our Y1J. So the minimum multiply the Y1J, it's pretty easy. We'll just take this one, multiply our 150. And this 150 is not going to change. So we want to fix it when we copy these cells to the right. So I'm going to fix the column number. Put a $sign before the column, and copy this cell here, so it will look like something like this. Okay, so it would be the minimum order size multiply the Y here. And this will be my left-hand side in one of the constraints. And my big M, so we'll need to find out the big M. The big M value in this problem is the upper bound of our X again. Okay, so for example, this big M is the upper bound of this X11 here. Okay, and this big M is the upper bound of our X12. So what will be the maximum value? How do we find out? It's assuming that company 1 only supply to project 1, no others. Okay, so it's the minimum value between the 450 and the 525, because company 1, if only it supplies to project 1, it can supply up to 525 units. But the project 1 can only receive, total needed is 450. So basically it's this 450. Just to make it copyfiable, we'll just make it to be, it equals to be, it's the minimum between this value and this value here. Now, how do we modify this formula here so that we can copy it all the way down to the right? If you take a look, this 525 value will not change, because when we are looking at this big M, they are all about company 1's supply. So company 1's maximum supply is 525 here. It won't change. And when we're looking at this second value here, this second big M, it's about company 1's supply to project 2. So this 550, the maximum value this X can be is the minimum between this value and this value. And then when we're looking at this third big M, it's the minimum between 300 and 525. Okay, so with this, we can just come here, fix this 525. We don't want it to move. So the column should not move. We'll put a $sign before it. And we do want those values to move. So let's just copy. Okay, so it does give us the minimum between the 350 and the 525. That's the maximum value that the X14 can be because if company just supply project 4, the maximum it can get is up to what it needs, the 350. So those are the big M, and we're going to get the big M multiply our Y. And this will be left-hand side of another constraint. So if we look at our constraint, we have this part and this part, and they are always the x1j values. If we want to make it easier, I'm going to just shift this here and put the x1j, or even more. Okay, so I'm going to put the x1j here and make them refers to the x1j value. So it's this one, and copy this other way. So it will refer to the x14 here. And oh, sorry. And then this equals to be here. I have those spaces here just to put the sign here. So it's the minimum times the y need to be less than equal to my x value, and my x value need to be less than equal to the big M times the y value. Okay, so this will be like my right hand side. Okay, and since the signs are all the same, I'm going to just merge them together. So here, it's the same. I can basically just copy it here and paste. This helps me to make sure that when I put them in the solver window, I know what to put. Now this is the first constraint, the company 1 side constraint. Now I'm going to put the second one. So the company 2 side constraint is they will not supply more than 200 tons to no more than one company. So I'll just put this max supply here. They will not supply more than 200. And if we look at our constraint for this one, what we did is make x2j less than equal to this 200 plus. This is basically the big M part. Okay, it's very similar to the learning curve problem. That's it's the maximum, the big M, subtract this 200 here. We use the 250 here, but we can find the accurate M here. So we'll just put 200 here for now. Okay, and then we'll do the Y. Now it's 2J's. So those will be my Y2J's. And this part represents, I'm going to put my left hand side, okay, or the right hand side in this case. It's the 200 plus the big M times the Y. Times Y. 2J. And now going to find out the big M first. The big M. So the big M is the maximum that company 2 can supply to the different projects. So it will be the minimum between the company 2's supply, okay, and project 1's demand. It's very similar to the previous one, except that here we're going to subtract this 200, because this part represents the amount supplied by company 2 to the different projects beyond the 200. So this value need to be fixed. The column should be fixed. And also the 450, that's this one. So this also need to be fixed. And we do want those towns to move. Okay, so you can see for the first one, it is 250. But if we move it here, for the other ones, the big M will change. So in the slide here, when we talk about problem, we use the 250 because this is a value that's bigger than the other ones. As long as the M value is bigger than the real big M value, you are okay. You will find the optimal solution. We just don't want to have a big M value calculated run that's less than the actual upper bound. And if we find the accurate, for example, 75 here, then it will help us solve the problem faster because the way the branch and the bound algorithm works. So the bigger those values, or like the farther away they are from the true bound, the more sub-problems the computer has to go through, and the more time it will take to solve the problem. But since this is a pretty simple problem, and with today's computer capability, there's simply no difference. Okay, so here we're going to put them as the 200 plus this times our big M. Okay, I'm going to fix the 200 again. 200. And then copy this other way. Okay, just click in the last cell you copied to see if it makes sense, if it's copied correctly. So it's the 200 plus y times the big M. Okay, so I just make this more accurate. It's the maximum supply plus the big times y. And we know that for this problem, the x need to be less than or equal to this right hand side. Okay, so the x2s, we'll just put x2j here. This equals to be the x2j. Make sure you be very careful referring to the right cell. Okay, so now it's the second one. It's the 2j's, so it's the second line in this table. Okay, and then here, okay, I'm going to just move it a little bit, and here, it's the x2j's less than equal to them. So merge text and so that means those ones, so the right hand side. Okay, so the right hand side is greater than equal to the x. Okay, or the x less than equal to this right hand side. The x less than equal to the right hand side. Now we're going to add the y's. So the y will take the sum equals to be the sum of all the y's. This one need to be less than equal to a 1 here. We'll just put a 1 here. Shaded as the right hand side. This is left hand side. Okay, so this take care of the second side constraint, the company 2 side constraint. Now we'll look at company 3. Company 3, it said that company 3 will supply a total supply of 200 or 400 or 550. Now let's look at our model to see how we do that. So our constraint is that the sum of all the supplies shipped out from company 3 need to be equals to 200 multiplied binary variable plus 400 plus multiply this binary variable plus 550 multiply this binary variable. And the sum of the binary variable will be less than or equal to 1. So that means we will need to have 3 cells to store these 3 binary variables. We're going to just put the Y3J. We only have 3 of them in this case, okay? This one is different from the first 2. Okay, so those are our 3Js. And here we'll need to take the sum product of them. And that's the left-hand side. So the left-hand side, total supplied. The total supplied equals to be the sum of company 3's. So the left-hand side, okay, total supplied need to be equal to, oh, I just need the equal sign here to remind me when I go to solver window to define my model later. This is just equal to the sum product of these 2 rows. And this one. Okay, so sum product of these 2 rows. If we look at our model, that's what we had. Okay, so the total supply multiply the binaries, and then we'll implement this part. Again, the sum of the binaries need to be less than or equal to 1. That's what we define in the constraint. Okay, so you see when you have the mass model laid out, it's very easy to put in Excel. For those ILP problems, you want to have all the mass models, all the constraints in the mass format laid out in a complete format before you go to Excel. Because if you just go to Excel, it will be very easy to miss a constraint. So the mass model lays the foundation of how you solve the problem. Okay. So here, this will be our left-hand side, our right-hand side. This will be our left-hand side. Right-hand side. Okay, so this is the company 3 side constraint. Now let's look at our model. So our model has the decision variables. We have a decision variable for each pair of the company and project. Objective function, the very basic transportation problem, the sum product of the unit cost and the shipments. Then the 2 groups of basic constraints for the transportation problem, and then the first side constraint, second side constraint, and the third side constraints. Now we are ready to implement this in solver. Okay, so our objective function is to minimize the total cost. So change to minimize here. Our variables are the xij's, all the y's, and these ones. Okay, so 1, 2, 3, 4. 4 groups. And now the constraints. I'm going to add the constraints. First constraint, oh, sorry, we forgot to highlight those in red. Let me just go to highlight them. So these will be the left-hand side. These are the left-hand side. These are the right-hand side. Right-hand side. Okay. See, the sum of the supplies less than equal to the capacity, and the demand are the equal ones. Okay, so we'll go back to solver. Constraints. The first group. So these ones need to be less than equal to the supply capacity. And the ones that received needs to be equal to total tons needed. Then we're going to add those side constraints. So you see we have all those side constraints highlighted with the signs indicated here. So it will be very easier now. We don't have to go back to the model to go back and forth to check. So the first one would be these ones. The left-hand side less than equal to the xij's, x1j's. Okay, that's the first one. And then this one, continue here, okay? This one less than equal to these ones. Okay, now moving to here. We'll do this one first. This less than equal to this one. And those ones greater than equal to. Even though we highlighted the xij's as like the left-hand side, but when you put it, as long as the sign, the greater than equal to, less than equal to sign are correct, then you don't need to really worry about I have to put like my left-hand side here, or they can be on the right-hand side as long as your signs are correct. Okay, and then this one here need to be less than equal to the 1 here. And this one need to be equals to this one here. Now make sure all your binaries are specified. Okay, so this is a binary. This is another binary set. And these ones are also binaries. Okay, so for the shipment, we don't really need to specify like they are any integers or so. We'll just make sure that they are non-negative. So make all unconstrained non-negative and use LP to solve. Okay, solver find the solution. All constraints and optimality conditions are satisfied. Yeah, again, once we get the solutions from solver, we want to make sure the solution makes sense. Because one problem with Excel solver is that even if it didn't solve the problem correctly, sometimes it will still give you values. Okay, we did read the message. The message says that optimality is achieved and all constraints are satisfied, but we still want to just check it. Okay, we have some side constraints like company's minimum size. Okay, so we want to make sure the minimum size here, company one. So company one did not supply any project less than 150. So you see the minimum one is 150 and the other get 0. So that's good. For the company two, it will supply maximum like more than 200 for no more than one company. So it actually didn't supply anyone more than 200. And then company three, the total supply can only be 200, 400, or 550. So if we look at this, the sum of these two is 400. So it supplied only 400 in total. So this is our solution. And we'll just do some final touch to make sure. So for example, this is a currency, and we don't want decimal point. So just change this to currency. And make it bigger, and because it's our objective function. Okay, and for those ones, if you want to put some, for example, this is the first constraint group, I'm just put a outside border, and then this is like the second group. Actually, I'm just going to put this entire thing. Okay, and here, this is the third group. Okay, and that's our model.